Hello, friends. Happy to have you with me today. Really excited to share with you more about the big integer and big decimal class inside Java. Today we're going to be working out of Liang's Introduction to Java Programming. This is going to be the 10th chapter, and we're in section 9, big integer and big decimal. And let's work through an example together. I think that'll help bring things together. So the example I wanted to work through is this large factorial. And I'm going to grab this line of code first, and let's get that pasted in. And I took the liberty, I went ahead, I made a new package inside my, I've got an existing project folder. Inside that project folder, I've got a new package that I just made and a new class for that. And here's that class, and here's that line of code. And so this line of code that we just pasted in, it says, hey, I don't actually exist yet. So we'll go ahead and create the custom method, and it says, so we'll actually change this to, I think, void, and that way we don't actually have to have a return statement. But let's go back to the example right quick in the text, and let's just grab this. Okay, so Daniel does leave it as a static return, and so he has it return the result. So we'll just go ahead and grab this. Got a couple extra words over here, so we'll have to fix those. You know what would make this actually easier? Let's just grab the whole thing. And so all the way down to that. Constant and multiplier, two words that we're going to have to delete out there. So let's just pop this in here. Control A, Control I, and then there's constant and multiply. So we could just get rid of those right quick. And then big integer, well, we need to import the big integer class. And so 50 factorial. Let's go ahead and run this. We've got, says it's got a reservation. They're all taken care of. Run it. 50 factorial, 3041409. 3041409, whole bunch of numbers with a whole bunch of zeros at the end. Okay, so let's look at what this code is actually doing. So this is just my boilerplate. That way I know where the code starts and the code stops. So we've got these two lines, and it says 50 factorial is 50 factorial. And then big integer result equals big integer dot one. And then it says for a loop, let's just multiply this factorial. Just multiply it basically n times the previous result. So every time we've got a result, and this result starts out as 1, and then we say result is multiply times a new big integer of, and this is how we convert this integer, whatever I is going to be. By the way, that's a bad name, so let's just rename that right quick. Refactor, rename, and let's just call that index. Now, Daniel picked a number to make a point, and the point is you can't necessarily do this with a long or anything like that. So let's play with this a little bit. Int. Actually, let's do a long our stopping point. Let's do our factorial. Equals, let's just start out with 2. And so what we'll do is we'll say our factorial plus is factorial of our factorial. And let's just run this right quick. Okay, so let's run through this. Result equals 1, and then for index equals 1. You know what? let's rename this right quick, because that's actually, let's call this stop index, because essentially our factorial is what we're using in this code for our stop index. So our factorial, what we're looking for the factorial in this algorithm, becomes our stopping criteria for our for loop. Okay, so our factorial is 2, so our stop index is 2. So index equals 1. We say result equals result dot multiply of big index. Okay, so 1 times 1 is still 1. Yes, I can do math today. And so we store that as 1. And then we say, now, change index, because the end of the for loop, you know what? Add the curly brackets. So I can say, yeah, end of the for loop here. That's when we execute the end of loop behavior. And that says, take index and make it 1 bigger. So index is now 2. 2 is equal to our stop index. And so we say result equals result dot multiply new big integer. And so index is now 2. And so we multiply our result, which is 1, times 2, and we get 2. And that is our result. And then we get down here, we index our index by 1. It becomes 3. 3 is not less than or equal to our stop index, which is 2. So we terminate the loop. Then what we have stored as result gets returned, and that return gets returned in this spot right here, which is 2. And then it says, bye-bye. So that is exactly what we would have hoped for. Let's repeat this exercise with a factorial of 3. So walking through the math, it's going to be 1 times 2, which is 2, times 3, which is 6. That returns that. And now let's do 4. 1 times 2 is 2. You know what? A lot of math. Starting to eat up valuable brain power. So let's just make some notes. By the way, I am just naturally really good at math. And so that is how I know that, 1 times 2 times 3 is equal to 6. The other thing that I realize is that's not true. And the trick on this is you're basically taking this entire line from up above, and then you just add 1 more number on the end, and that's what you're actually multiplying. So you multiply, so example, this was 1, 2 times 3, which got you 6. Well, now we're going to do 4 factorial. So you add a 4 onto the end, and you just multiply a 4 times the previous number to get you 24. And so that checks out with this. Keep our spacing. Now check this out. Times 5. 5 times 24. Well, 5 times 4 is 20, plus 5 times 20 is 100, so 120. Yeah, and if you take 24 divided by 2, you get 12, times 10 is 120. So yeah, that should be 120, I think. And that's actually 5 factorial. And let's run that. 120, yay! All right, so we're gonna stop there. We're seeing that the pattern works. We're seeing that the code works, and we're also seeing that we can always, just change that to 50, and we get that number. And as they used to say in my old college textbooks, to fill in the what they would do typically is dot 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 50 factorial equals and what they would say is something cheeky like, and so we leave it to the student as an exercise to fill in the numbers in between 5 and 50. But I mean, the other fun thing about this is now that we've got the code set up this way, we can start to do some ridiculous things. 500 took at the blink of an eye. Let's 5,000. Let's see how long that takes. Starts to make it smoke just a little bit. 50,000. Hey, there you go. Look at that. Now we're starting to let some magic smoke out. Hey, it took a little bit longer, but not that long. Stick another 0 on there. And the whole reason of this is understanding this is a for loop and a multiplication, and it is making that simple code, like a handful of lines of code, is now making my processor work fairly hard. Now, I'll be the first to admit my processor may not be a modern processor, but it don't do too bad. But anyway, I hope you had some fun with this. I hope you get to poke around and play with it. Enjoy yourself a little bit, have some fun with it. I always enjoy stuff like this, and the big integers are fascinating because the thing I love to say is now the calculations you can do are nearly limitless. So that's a lot of fun for me. So with that, I thank you all for your time, and I hope you have a wonderful weekend.